Hello everyone. Here is the video in which we are going to learn about a sorting technique called as selection sorting. So, selection sorting is something, it's a sorting algorithm. So, which treats the input as two parts, a sorted part and an unsorted part, and repeatedly selects the proper next value to move from the unsorted path, the one part of the input, to the end of the other part, the sorted path. So I'm going to show you this process through various animations. But before that, let's see what is the meaning of sorting. Sorting means converting a list of elements either in the ascending order, increasing order, or in the decreasing order. That means the descending order. Let's see one example. These are the methods. So let's say the first list is giving to us as 7, 9, 3, 18, and 8. Total 5 set of elements are present in the list. And here we are supposed to keep track of the indexes of each elements in the list. So 7 should be in 0, 9 should be in 1, 3 is in 2, 18 is in 3, and 8 is in 4. So the indexes will vary from 0 to 4, and the total length is here 5. Length is equals to the total number of elements present in the list. So in the first state of the selection sort algorithm is that we need to define or find out which one is the smallest one. So here in the list, the smallest element is 3. And see, these are the indexes. I just tried to point out all the indexes. So we are going to basically work with the indexes. So indexes play a major role in this algorithm. So here, after finding out the indexes of all the elements in the list, as well as the smallest element, which is 3 here, we are supposed to swap the first element with the smallest. Why? Because we need this list to be sorted in the ascending order. That means in the increasing order of all the elements in the list. So to do that, we want the smallest element in the total list to be in the first position, and the greatest, that is the largest element, which is 18, to be at the end of the list. To do that, after finding the smallest element in the list, we are supposed to take it to the first position. So that is why one swapping method or process is to be performed to swap the location of 7 with 3. So 0 with 2 will be swapped. So after swapping that or interchanging that, the list will be modified to like this. So 3 comes to the first position 0, and 7 goes to the position of 3, that is 2. Okay, so now we just sorted the first element. The next thing is that the rest of the elements 9, 7, 18, 8, we need to find out which one is the smallest now. So let's see the next step. So in the new list, leaving the first element 3. Why? Because 3 is the smallest element. That's what we actually needed here. We want the smallest in the beginning of the list. Now in the rest of the list, that is 9, 7, 18, 8, we need to find out which one is the smallest. So now we determine the smallest is 7. Now the second element 9 is to be swapped with 7. Why? Because we don't want to touch the element 3 further, because it's already sorted as per our need. So let's see what happens now. Now 9 is swapped with 7, so 7 comes to the second position. Now we are just left with 3 next elements, 9, 18, 8. So now the next thing is that to find out the smallest in between 9, 18, 8. So 8 is the smallest element here, and swapping the third element, that is 9 with 8, we will be having this ordering right now. So 3, 7, 8 are now sorted, and we are just left with two rest elements, that is 18 and 9. So the smallest element is here 9, and 9 is supposed to be swapped with the fourth element, that is the 18 at index 3. So after sorting, we are having the list in the sorted order. So in here, we are supposed to keep track of the length of the list. So there should be one condition in the loop. Why do we need a loop? Because we are just swapping all the elements in every step after determining which is the smallest one. So when you reach the last index 4 or the length of the loop, then there you will stop. So we will see that condition in the algorithm. Okay, here I'm going to show you the algorithm. So the first least is given to us. Same example I am using. So we need a for loop to walk through all the list element in the list. So it should start at the index 0 and it should go up to length -1, that is 4. So when you reach the last element, there are no other further elements to go through the process, so that's why we just have to stop there. So that's why the last index is considered like this: number start length -1, that is equals to 5 minus 1. The length is 5 minus 1, which is 4. So the 4 index is the last element. So when we reach the fourth one, 4 index, then that we just have to stop. That is the for loop. And then the next step, you always try to find out which one is the smallest element. So when you are having the I index as 0, you are supposed to find out which one is the smallest. So the first smallest element is to be considered as the first element by default. And then we are taking another one index variable as j. So j will start from the I plus 1. So I is here 0, so j will be I plus 1, that is 1 up to the length. So j will continue for I plus 1 up to the number start length. So actually it's less than length, so it should be always number start length -1. So for I equals to 0 in the first iteration, it will try to find out the smallest element in all the list provided here, and from that we try to find out the smallest element. So once we try to find out the smallest one, we are supposed to shift or swap the elements with the first element with the smallest one. So that is what we are trying to do here in the swapping. So we are trying to assume one temporary variable here. As per the assumption, the first numbers I, that is the first element 7, will go to the temporary variable. Then whichever is the smallest index, that is 3 here, the smallest index will be 2. So 0 1 2. So 2 will go to the numbers of I, that is numbers of 0, the first position with 7, and then the numbers of index smallest, that is 2. Here first we have assigned to the temp as 7, so 7 will go to the smallest index, that is 2. So the next step you will have like this. So now in each iteration of the outer for loop, like I equals to 1, then I equals to 2, I equals to 3, and I equals to 4. So for all this, we are supposed to repeat the same process again and again. So once we do that, we are going to um, have the sorted list as per the selection sort algorithm gradually in this way. And by the end, when you reach number start length -1, which is 4, so there you just have to stop, because we don't have further any additional elements to compare with. So now I'm going to show you how to develop the selection sort program in Java using the algorithm that we just went through. So in the main function, public static void main function, we are first supposed to create the list. So one numbers array is created with all the list elements. I'm not using the same elements that I have just shown you in the example. There are some more elements: 1 2 3 4 5 6 7 8. Total length is 8 here. And here first we try to print all the unsorted elements in the output. That's why this is the for loop. So first it will print all the elements in the unsorted array. The next thing is that with using the array as numbers, we are supposed to implement the selection sort algorithm. So one function is to be constructed, and when the function call is made with having the argument of the numbers array as a list, we have to implement the class selection sort with having the function definition, that is selection sort numbers. So here it is returning void type, and taking the array numbers as the formal argument. So we are having all this set of variables I, j for the for loop, outer for loop, inner for loop, index variable, index smallest for keeping track of the smallest element in the list, and then the temporary argument for the swapping operation. So here I'm just going to add the same algorithm I just have shown you earlier. So the same thing. So for each element for in the outer for loop, we try to find out which one is the smallest, and whenever we find the smallest, then we have to make the swap operation. So this is the total your shorted. So after we are done with the selection sorting, then we have to print the elements in the sorted order. So for that, we have to add a for loop that will display the elements in the sorted order in this way. Okay. So this is all about your selection sorting. Now let's see. mm, one important that is a concept about the time complexity of the sorting. So anytime at any point of time we are going to learn about any sorting technique or searching technique, we are to be concerned about the time complexity. So selection sort may require a large number of comparisons. So always the selection sorting algorithm is considered as order of n square. So how? Let's say our list has n elements and the outer loop the with the index variable I, so it always executes n minus 1 time. So if you have n number of elements, so it should go up to n minus 1 times, because after n minus 1 index we don't have no additional elements to compare with. Now for each outer loop, the I loop, the inner loop actually executes on an average of n divided by 2 times. So it's not actually n times, as we try to compare the first element with the smallest one always. So because of that, the inner loop will execute on an average or run on an average of n by 2 times, n divided by 2 times, like a half of the total number of elements. So if we take these amounts into consideration, so total number of comparisons will be proportional to, for each outer loop iteration n minus 1, so each outer loop will compare with inner loop n by 2 times. So it should be n minus 1 multiplied by n divided by 2. So that will be n square by 2 multiplied by your n by 2. So here um, the most largest comparison or the expression which will actually affect the time complexity will be n square. So that is why it is considered as the n square, order of n square. This is all about selection sorting.